Hey everybody, so today what we're going to do is we're going to solve this specimen paper that has been designed by Cambridge for your upcoming May-June 2023 examinations. It's the MCQ paper for your O-levels, right? And I was a little lazy. I was like, who is going to solve this, man? You guys could do it on your own. But I was being spammed on my Instagram, and I don't know how you guys found my personal number, and I was getting spammed. They said, please, we need a video on, the May-June specimen paper for O-levels, because I feel like there is not much substance available on YouTube for it, and not much satisfactory explanation available might be, right? So I've already written my name so as to save time, and let's just hop into the questions, right? So question number one says, stearic acid has a melting point of 69 degrees Celsius. Now, what is a melting point? A melting point is basically the constant temperature at which a solid changes its state into a liquid, right? Once you're heating the substance up. So, you need to understand that the melting point and the freezing point are the exact same thing, and the boiling point and the condensation point are the exact same thing. The only thing that is different is whether you're heating the substance up or whether you're cooling the substance down. So if I'm heating the substance up, I call it the melting point, and if I'm cooling the substance down, I call it the freezing point. And the reason to that is pretty simple, and I've explained it in the class as well, that once you reach this constant temperature, let's suppose here this is that constant temperature, right? You will end up with a solid as well as a liquid, right? So a solid would be here and a liquid would be here. The only difference is if I'm cooling it down, then this solid and liquid, the liquid that is present would convert into a solid, and from here on end you would just end up with a solid, right? So that's why the substance actually freezes, because you're cooling it down, you're strengthening the intermolecular forces of attraction, so the amount of liquid that would be present would convert into a solid. But if I'm heating the substance up, the amount of solid that would be present would be converted into a liquid, because I would be, breaking the intermolecular forces of attraction. I would be breaking those bonds that were holding the solid particles in place, right? That's why the temperature is constant, because the temperature is no longer used to raise the temperature. The heat is no longer used to raise the temperature of the substance. Rather, it is used to break or overcome the intermolecular forces of attraction. And a practical example for that is like H2O solid and H2O liquid, right? So if I ask you guys, what's the boiling point of what's the melting point of H2? You guys tell me it's 0 degrees Celsius. If I say what's the freezing point of H2, it's again 0 degrees Celsius, right? The only difference is if I'm cooling it down, I call it the freezing point. If I'm heating it up, I call it the melting point, right? And the process is called melting and the process is called freezing. Okay? So which process occurs between 8 and 12 minutes? Let's first understand what is happening. So a heated sample of pure stearic acid is cooled, right? So if it's being cooled, that means that you are actually going to be performing what? You're actually going to be performing either freezing or condensation. Now, the melting point is given 69 degrees Celsius. And if you check this out, it says which process occurs between 8 to 12 minutes. Between 8 to 12 minutes, you are actually coinciding with a value that is 69 degrees Celsius. So we don't call it melting. We say that what is happening? Freezing is taking place, right? Because 69 degrees Celsius was the melting point, so that therefore it should also be the freezing point if you are cooling that substance down. So this process is basically called freezing, right? Why is it not condensation? Because it's not given us the boiling point, it has given us the melting point. Melting point and freezing point are the same, boiling point and condensation point are the same things. Okay? Which statements are correct? The volume of a gas at constant pressure increases as the temperature increases. Obviously, if the temperature of gas particles are increased at a constant temperature, at a constant pressure, what would happen is that the volume would increase, because increasing the temperature will lead to the gas particles gaining that kinetic energy, and then therefore they would move faster and further apart, and therefore the volume would increase. So one is absolutely right. When the pressure of a gas is increased, the particles move close together. Yes, that's also true, because if you guys have like a piston and these were the gas particles previously, and if you now push the piston inwards, applying somewhat of a force, like let's suppose the piston is now here, now the gas particles have actually moved closer together. So yes, 2 is also right. If I look at 3, it says the pressure of a gas at constant volume decreases as the pressure increases, so as the temperature increases. So they're saying temperature but ahead the pressure of the gas is actually decreasing. That's not the case, because if you're increasing the temperature at a constant volume, the gas particles, they gain that kinetic energy, they collide with each other and the walls of container more frequently, therefore exerting more pressure, because pressure is force per unit area. The more frequently they collide, the more force they exert sorry, per unit area. I didn't know, I just choked on my own spit. Yeah, so the more force they exert per unit area, and that's how the pressure increases. So pressure and temperature have a have a direct relationship, not a constant, a direct relationship. So if the temperature is increasing, the pressure should increase at a constant volume, it shouldn't decrease. Therefore 3 is wrong. So 1 and 2 are right, and that's why B is the right option in Reno. It says which substance would diffuse most quickly. Now, diffusion depends on two things. It depends on temperature. The rate of diffusion depends on two things. It depends on the temperature and it depends on the relative molecular mass, right? It depends on the MR. Now, let's first of all take into consideration the MR. The greater the MR, the slower it diffuses, because I gave you guys the example. Let's suppose there's a guy who weighs 300 pounds and then there's this dude who weighs like what, 80, 90 pounds. Who will win a race if they run together? Be realistic, guys. Obviously, the guy who weighs 80, 90 pounds, 300 pounds man wouldn't be able to even walk even a second, right? That's why the fatter the molecule, the more MR it has, the slower it diffuses. Now, if you check carbon dioxide and neon, neon is basically, it has an MR, or you could say an AR of 20 AMU. Because it's an element, we don't call it an MR, we call it AR, right? We just look at the relative mass. And carbon dioxide is CO2. Carbon is 12, oxygen is 16. You 16 times 2 because you have 2 oxygen, that gives you 44, right? So which one is fatter? Carbon dioxide is fatter compared to neon. That is the reason carbon dioxide would diffuse slower compared to neon. Now, if it comes to the temperature, the greater the temperature, the more kinetic energy the particles have, the greater, the greater their speed. Because if you realize, if you're increasing temperature, you're basically increasing kinetic energy. And if you know a little bit of physics, just for the physics geeks, kinetic energy is half mv squared. So if kinetic energy is increasing, basically the speed is increasing. So the rate at which particles diffuse is increasing. That's why neon at 0 degrees Celsius should not be my answer. Neon at 25 degrees Celsius should be my answer. Okay. Which diagram shows the arrangement of particles inside a balloon containing a mixture of nitrogen? Nitrogen is N2 gas and oxygen is O2 gas, right? And saying which one shows that. Now, nitrogen atom is denoted with a small dot, so obviously there should be two small dots, two small black dots joined together, because nitrogen gas is N2, and oxygen atom is represented with a hollow circle. Therefore there should be two hollow circles, because oxygen is not O, oxygen is O2. It is a diatomic molecule. It exists in the form of O2 as a gas, right? So obviously A is wrong and obviously D is wrong. It's basically D is showing an oxygen atom being bonded to a nitrogen atom. That's wrong. Okay? Between B and C, which should be our right answer? Between B and C, obviously C should be our answer, and the reason for that is that gas particles, they move randomly at high speeds, and according to Brownian motion, they move, all particles, they move in a zigzag motion. So obviously, due to the random motion of gas particles, they won't be arranged, oh, nitrogen would be at the top and oxygen would be at the bottom. Rather, they would be more randomly arranged, and that's why C is the right option, Reno. Now, question 5 says, the ion Q2 plus has 3 complete shells of electrons. What is Q? First of all, it has a 2 plus charge, therefore it should be towards the metal end, right? It should be a metal. That's why oxygen and sulfur are automatically wrong, because they make an anion, they make a negative ion rather than a positive ion. Between calcium and magnesium, which one should be the answer? And I was saying the ion has 3 complete shells of electrons. If you check calcium out, calcium is basically 2040 and magnesium is basically 1224 in your periodic table. Now 20 means it has how many electrons? It has 20 electrons. But if you have a calcium 2 plus ion, that means that 2 electrons have left. So now calcium would have 18 electrons, and if I were to write those 18 electrons, if I were to write its electronic configuration, the first shell holds up to a maximum of 2 electrons, the second shell holds up to a maximum of 8, and the third would hold up to a maximum of 8. And here you go, these are your 3 complete shells, and therefore the answer is calcium. The reason why magnesium is not the answer, because if magnesium has a charge of 2 plus, there are only 10 electrons left, and the first shell holds up to a maximum of 2 and the second holds up to a maximum of 8. Therefore, although they are complete electron shells, but they are not 3, they are 2. That's why this is not the right option, right? The symbols for 2 ions are shown. Which statement is correct? Okay, so let's first of all, they're asking us about neutrons, protons, and electrons. So let's write this down. Fluoride ion, it actually has 9 protons. It has a negative charge. That means that it had 9 electrons, but since it has a negative charge, 1 more electron has been gained. Now it has 10 electrons, and the number of neutrons can be found by taking the nucleon number and minusing it from the proton number, right? And the reason for that is nucleon number is the number of neutrons plus protons. That's equal to the nucleon number. number or the mass number. And what you do is, if you want to find the number of neutrons, you just take the protons on the left side of the equation. So mass number minus the number of protons would give you the number of neutrons. So 19 minus 9, that gives me 10 neutrons, right? And if I talk about sodium, it has 11 protons. It has a plus charge, which means that first it had 11 electrons, but this plus means that an electron has basically left it, and that's why it's a positively charged ion. Therefore you have 10 electrons. And if I check about the neutrons, 21 minus 11, that gives me 10 neutrons, right? So the fluoride ion contains more electrons than, no, both contain the same number of electrons, that is 10. The sodium ion contains more neutrons, no, both contain the same number of neutrons. The two ions contain the same number of electrons as each other, absolutely, that's 10, that's 10, therefore C is the right option. D says the two ions contain the same number of protons, no, F contains 9 protons and Na contains 11 protons, right? Na has 2 more protons. Moving on, it says two isotopes of chlorine are chlorine 35 and chlorine 37. Using the isotopes, how many different relative molecular masses are possible for this compound? Okay. So C2 and H3 would stay the same. The only thing that would be different is the mass of these. So if you change the mass, if you change these isotopes in these three Cls, you would end up with different molecular masses, right? How do I know that? I know that if you see for these three Cls, if I say all three Cls are chlorine 35, that would give me a different mass, right? If I say all chlorine should be 37. All these three Cls are isotopes which are chlorine 37. That would give me a different mass. If I say the first chlorine is 35 and the next two are chlorine 37, that would give me a different mass. And I could also say that one chlorine is Cl35 and the other are 37, sorry, and the other two are Cl35, right? That would give me a different mass. Now some of you might say, sir, these four would all give you different masses, right? Because if you add all these three up, three up, they would give you different numbers, so the different masses, right? Now some of you might argue, sir, what if the first chlorine is 37, the second is 35, and the third is basically 37 again? And I would say, you dumbos, if you add these three up, you would end up with the exact same thing that you've written here, right? So 37 plus 35 plus 37 is equal to 35 plus 37 plus 37. They're just asking you how many different relative molecular masses are possible. These two are the same thing. So the number of different molecular masses that are possible are just 4. It does not matter if you write this first or second, we just have to add these three up and all these 4 should be different from each other. Therefore C is the right option. Okay? What happens to an atom of group 2 element when it forms a compound with oxygen? Obviously group 2 element would be a metal. Let's suppose we take magnesium for an example and wants to form a compound with oxygen. It will make an ionic compound because an ionic bond would be formed. Magnesium is going to lose 2 electrons, the oxygen is going to gain those 2 electrons, and there's going to be a strong electrostatic force of attraction which would hold these two oppositely charged ions in place. Now A says it bonds with 2 atoms of oxygen. No, that's only 1. It receives 2 electrons. No, it donates. It transfers. It shares 2 electrons. No, it's not a covalent bond. It's an ionic bond between metal and non-metal. It transfers 2 electrons to an oxygen atom. Absolutely, it does that, right? And that's how an ionic bond is formed. Ethane, C2H6, and ammonia, NH3, are covalent compounds. The dot and cross diagrams of these compounds are shown. Which statements are correct? A molecule of ethane contains twice as many hydrogen atoms as a molecule of ammonia. We just have to use our eyes and look here, right? So ammonia has 1, 2, 3 hydrogens and ethane has 6 hydrogens, and yes, they are twice as many. So 1 is right. 2 says an unreacted nitrogen atom has 5 outer electrons. Absolutely, it's in group 5. It will have 5 outermost electrons in its outermost shell. And if you don't trust me, you could just check the periodic table out, and if you check nitrogen, it actually has 7 electrons in total and 7 protons, right? A neutral atom of nitrogen has 7 electrons. So the first shell would have 2 electrons, and the second, now how many are left? 5. So the outermost shell, which is the second shell, would have 5 electrons in its outermost shell. So yes, 2 is also right. 3 says in a molecule of ethane, the bond between the carbon atoms is formed by sharing 2 electrons. Yes, this carbon will share 1 and this carbon will share 1, right? 1 from each carbon atom. Absolutely. So that's also true. Therefore A is the right option, right? Question 10 says a compound contains 70% by mass of iron and 30% by mass of oxygen. What is the empirical formula? For empirical formula, let's write 70% of iron hai and you have 30% of oxygen. So now what we do is we divide it by their ARs, or you could call them their molar masses, but who cares? We divide it by their ARs, which is 56 for iron and 16 for oxygen. What we end up with, 70 over 56, let me use my calculator, you get 1.25 for iron, that's iron, and that's oxygen. So 1.25 for iron, and 30 divided by 16, that gives me 1.875. And the next step for empirical formula was divide with the smallest number. So smallest is 1.25, you divide it with the smallest ratio, which is 1.25. Here you would get 1 ratio 1.875 divided by 1.25, that gives me 1.5. Now we knew that empirical formula is defined as the simplest whole number ratio, and this is not a whole number, it's in points. So what should I multiply 1.5 with to get a whole number? Obviously 1.5, if I multiply this with 2, I would get a whole number, which is 2 ratio 3, right? Because 2 times 1.5 is going to give me 3, and if I want to multiply this 2 with 1.5, I'll have to also multiply it with this one, right? Because in order to make the ratio equal. So what is the empirical formula? It's going to be Fe2, because you have 2 irons and you have 3 oxygen, so Fe2O3 is the empirical formula, and that's why B is the right option. Even if you use your brains, man, just think about it for a second. Iron, oxygen, see here the Fe3O2 is basically showing you that the iron had a 2 plus charge and O had a 3 minus charge. That's why when you cross multiply you get Fe3O2. And this is so stupid because oxygen never makes a 3 minus ion, right? So C is the wrong option. If you check here, it's again showing you that iron is making a 4 plus ion and oxygen is making a 3 minus. As cross multiply you get Fe3O4. Both of these are not possible, so D is also wrong. Here FeO, Fe is 2 plus and O is 2 minus, that's why you have FeO. So between A and, even if you did not know how to calculate this, you would have a 50% chance of getting this MCQ right, because you would know the concept. But obviously you should know how to solve this. That's why we went for B, not A, because there was an option between A and B if we were to just make an educated guess. Okay? The equation for the reaction between ethine and oxygen is shown. When the equation is balanced, what is X? Pretty easy. It's 2C2H2 plus XO2. We don't know how much O2 is, and carbon dioxide is Y, and water is as it is. Now, I gave you guys the general balancing equation for it, but I said don't use that general balancing equation. Always what you do in combustion reaction is balance the carbons, then balance the hydrogens, and in the end balance the oxygens. You will never get it wrong, right? So you have 2 times 2, you have 4 carbons on the left hand side. How many carbons, and you have 1 on the right? So what should you multiply 1 with in order to get 4? X equals 4. So you would insert this beautiful 4 right here. Okay? Then you check the hydrogens out. You have 2 times 2. You have 4 hydrogen atoms on the left hand side. You should have 4 on the right hand side. Now how many do you have? You only have 2. So what should I multiply 2 with in order to get 4? X is equal to 4 over 2. That gives me a beautiful 2, and you insert that 2 here. Now let's count the oxygens. You have 4 times 2. That's 8 oxygens plus 2, because 2 times 1 is 2. So 8 plus 2, you have 10 oxygen atoms on the right hand side. Let me write the O a little bigger so it's not considered as 100. So 10 oxygen atoms on the right hand side. How many do you have on the left? 2. So what should I multiply 2 with in order to get 10? So 2 times what is 10? X equals 5, right? So you beautifully insert a 5 here, and that's why D is the right option. Okay? 25 grams of hydrated copper sulfate crystals are heated to blah blah blah. What is the mass of anhydrous copper sulfate from? So it is basically telling you that you have hydrated copper sulfate crystals, and you want to find this out, right? And the way we did it was we never used any formulas. What we did is we just use a simple map. So you are given the mass, and you know that you could go from the mass into the moles of this hydrated salt, and then from the moles of hydrated salts you go into the moles of the substance that is required, and then from that you go into the mass of that substance. Now, how do you go from mass to moles? We use the molar mass. You know that 1 mole of copper sulfate hydrated salt would have a mass of how much? You calculate it right here. So copper sulfate is 160, that's given. H2O is 18, but how many do you have H2Os? You have 5 of those. How do I know H2O is 18? It's already given, right? So you have 5 H2Os, that's why I times it by 5 and I add them together. So 160 plus 18 times 5, that gives me 250. So 1 mole of hydrated copper sulfate would have a mass of 250 grams. And if I have 25 grams of hydrated copper sulfate, how many moles of those would you have? You cross multiply 25 over 250, that gives me 0.1 moles. Okay? And then we go from moles of hydrated copper sulfate into the moles of anhydrous copper sulfate through the equation. So 1 mole of hydrated copper sulfate gives you 1 mole of anhydrous copper sulfate. So if it's 1:1, therefore if you have 0.1 moles of hydrated copper sulfate, you would get 0.1 moles of anhydrous copper. So like this, 1 mole of hydrated gives you 1 mole of this. If you have 0.1 mole of hydrated, how many of anhydrous would you have? That's x equals 0.1, right? And then you go from the moles of copper sulfate, anhydrous copper sulfate, into its mass. You know that 1 mole of anhydrous copper sulfate has how much mass? It has a mass of 160 grams. I'm not using formula, guys who are oblivious to this method. I've taught them in my live classes. I've taught multiple methods of doing moles, and students found this the easiest, so I just stuck with this, right? And there's one more method which students found ultra easy, and that's uploaded to YouTube, right? So 1 mole has 160 grams, and if you have 0.1 moles of copper sulfate, how many grams would you have? That's x equals 0.1 times 160, that gives me 16 grams. And do we have 16? Yes, we do. B is the right option. The relative formula masses of 4 compounds are given. A student has 1 gram of 1 gram sample of each compound. Which sample contains the highest number of moles of oxygen atoms, right? So it's given you the compound, and you have to perform interconversion. You're not going to go into stoichiometry because you're just going to play around in this same compound. Now, what was the map for that? We said you have mass, you have moles, and then you have molecules, or you have atoms. Okay, so what we do is we are given with the mass of each compound, and we use the relative formula mass to find the mole of this compounds, how many moles of Al2O3 are present, and then from the moles of Al2O3 we use the hidden relationship to find the moles of oxygen present. And obviously the number of, okay, it's all asking us the moles of oxygen atoms, right? It's not asking us the molecules or the atoms of oxygen, it's just asking you the moles. Okay, let's do this. So we know that in 1 mole of aluminum oxide you would have a mass of 102 grams, because that's already given. So if you have 1 gram of aluminum oxide, how many moles would you have? You have x is equal to 1 divided by 1 over 2. That gives me 9.8 in 9.803 into 10 raised to the power minus 3 moles of aluminum oxide. And how many moles of oxygen atoms are there in 1 mole of aluminum oxide? 3. So you times this by 3. So x equals, times it by 3, that gives me 0.02941. That's for 1, right? So this is the number of moles of oxygen atoms that are present, not the atoms of oxygen, just the number of moles of the atoms, right? Here you know that in 1 mole of copper oxide you have 80 grams. If you have 1 gram of copper oxide, how many moles of copper oxide would you have? And that's x. 1 divided by 80, that gives me 0.0125, and you times it by the number of oxygen atom, the number of moles of oxygen present, that is 1 in this case, so that gives me 0.0125, right? So 2 gives me this many moles of oxygen. If I check 3 out, I reckon it's a D, man, but let's check them out. 1 mole of H2SO4 has how many grams? It has 98 grams. That's given. If you have 1 gram of H2SO4, how many moles would you have? That's x. Cross multiply 1 over 98. That gives me 0.0102, and you times it by the number of oxygen, the number of moles of oxygen atoms present. These are actually 4. We are using our hidden relationship. This gives me 0.040816, right? And D, so it's obviously greater than this and this, therefore A and B are automatically wrong. And if you check D out, you have, you know that in 1 mole of HNO3 you have 63 grams. That's the molar mass. And now we need to find A grams of HNO3. How many moles would you have? That's x. 1 divided by 63, that gives me 0.01587, and you times it by the number of moles of oxygen present, which are 3. So you times this by 3, and that gives me 0.04761, and that's the greatest. 0.0408, and this is 0.0476. So 476 is greater than 408. That's why D is obviously the right. So I hate these connectivity issues. I got a call and my recording automatically stopped, right? I hate it. So moving on with question, I solved the entire question 14, and then I came up with B as the answer, and then I realized that it wasn't even recording. Okay, so moving on with question 14, it says 50 centimeter cube of this much concentration of silver nitrate nitrate is added to this much volume of this much concentration of sodium iodide in a beaker. Now if you have silver nitrate and you add it to sodium iodide, what would happen is a precipitate would form, because that's a precipitation reaction. Silver iodide is an insoluble salt that would be formed. That's basically yellow. AgI would be formed, and then what's it called, a solution would be formed for NaNO3 because that's soluble, right? So NaNO3 aqueous would also be formed. Okay, that's what we know. And the examiner is saying after the reaction solid silver iodide is present in the beaker. Obviously solid silver iodide is formed due to a precipitation reaction. This is going to be present, and I'm saying what else would be present. Obviously sodium nitrate would be present because that's going to be formed. So between all these three reactions there's only one option which does not contain sodium nitrate, and that's going to be C. That's why C is the wrong option, because not only sodium iodide, sodium nitrate will. Now between AgNO3 not only sodium nitrate would be present. You might be, tempted to go for D, but the problem is that you are given a volume and a concentration here and a volume and a concentration here, which basically is a, an identification that it's a limiting and excess question, because 1 mole of AgNO3 would react with 1 mole of sodium iodide, which means that the amount of AgNO3 you would have will react with the same amount of NaI, but you're given different amounts, right? So the smaller one would actually be all used up, and the one which would have more moles, that would be left at the end, which would be excess, and that would also be present in the beaker. So what we have to do is we have to find the moles of silver nitrate, and we have to find the moles of sodium iodide. And the way we could do that is, obviously we know that you have 0.1 moles of silver nitrate in 1 decimeter cube of silver nitrate, which we can call 1000 centimeter cube, because the other volume is in centimeter cubes. So we could say you have 0.1 moles of silver nitrate in 1000 centimeter cube of silver nitrate. So how many moles would you have in 50 centimeter cube of silver nitrate? That's X, cross multiply, you would get 50 times 0.1 divided by 1000. That gives me 5 into 10 raised to the power minus 3, which is equal to 0.005, right? That's how many moles of silver nitrate there are. And let's find the moles of sodium iodide. You know that you have 0.05 moles in 1000 centimeter cube of sodium iodide. So this many moles are in 1000 centimeter cube. How many moles would you have if you had 150 centimeter cube of sodium iodide, right? You cross multiply, X equals 150 times 0.05 divided by 8000. That gives me 7.5 into 10 raised to the power minus 3, which is also equal to 0.0075. Now which one is greater, 0.0075 or 0.005? Obviously 0.0075 is greater. Think about it like this, this 5 would round off and you would have 0.008, right? And this is 0.005. 8 is obviously bigger than 5. That's why, out of this 0.075, 0.005 would be used up, and you would still be left with 0.0025. That would be in excess, right? So obviously sodium iodide would also be present in the ions of sodium iodide, or the aqueous sodium iodide would also be present. So sodium nitrate is present and aqueous sodium iodide is present. That's why B is the right option. This was actually a good question. Question 15 says 0.1 mole of the hydrocarbon is burnt. What is the volume of carbon dioxide produced? You are given the moles of the hydrocarbon. You go from the moles of one hydrocarbon to the moles of carbon dioxide, and then you go from the moles of carbon dioxide into the volume of carbon dioxide. And how do you go from one moles to the other moles? Obviously we use the equation. We know that through the equation 1 mole of this hydrocarbon gives you 5 moles of carbon dioxide. So if 1 mole of this hydrocarbon gives me 5 mole of this carbon dioxide, what if I have 0.1 mole of this hydrocarbon? You would end up with X equals 5 into 0.1. That gives me 0.5 moles of carbon dioxide. And from the moles of carbon dioxide you could find the volume, because you know that 1 mole of any gas at room temperature and pressure would occupy a volume of 24 decimeter cube. So if you have 0.5 moles of that gas, how much volume would you have? That's X. 0.5 times 24, that gives me 12 decimeter cube. And is 12 there? Yes, D is the right option, right? That was a little too much. Let's circle it a little more smoothly and gently, right? Question 16 says carbon electrodes are used to electrolyze aqueous copper sulfate. Obviously if you have aqueous copper sulfate, you'll have the copper 2 plus ions, the SO4 2 minus ions, you'll have the H plus ions and the OH minus ions. And it's saying that carbon electrodes are used, which means that graphite is actually being used, right? And this is my entire electrolysis chamber. Now what would happen is copper 2 plus has a greater discharge power than H plus. It's more reactive. That's why it's going to go towards the cathode and be deposited as copper solid. So copper 2 plus gains 2 electrons at the cathode, becomes copper solid, which is a pink solid. So we say that at the cathode a pink solid forms, a pink solid forms, a pink solid forms, therefore B is obviously eliminated. Then what would happen at the anode? The hydroxide ion would win, because we've learned the rule that the hydroxide ion will always win even if it's dilute or concentrated. The only difference would be in concentrated if you have a halide ion. So if you have chloride ion, iodide ion or bromide ion, that would win the race for concentrated solutions only. Even in dilute, other than these three, hydroxide would win even in dilute, right? But in concentrated, other than these three, the hydroxide would win, right? So that's the exception for if it was concentrated. So even if it's concentrated or diluted here, doesn't make a difference, because the hydroxide ion would win. 4 hydroxide go together to give you guys 2H2O, 1 O2, and each hydroxide loses an electron, so 4 electrons are lost. And obviously a colorless gas is given. That's why C and D are wrong and A is the right option. And the blue color fades. Now the reason why the blue color fades is because the blue color is because of the copper 2 plus ions. So if they are getting deposited at the cathode, obviously the Cu2 plus ions are finishing, therefore the blue color should fade. Okay? Electrolysis is used to plate a metal coin with silver. You could do that because you could use silver as your electrode, which would be the anode, and the metal coin should be at the cathode because you want the metal ions to be deposited on that, and you would use an electrolyte, which would be a soluble compound of silver, more like silver nitrate or something, right? So that's what we use. You should have the Ag plus ions or the NO3 minus ions, and you dissolve it in water to give you the H plus ions and the OH minus ions as well. Now coin should be at the cathode because you want the H plus ions to be attracted to it, and unlike charges, they attract. So anode and anode are wrong. They should be at the cathode, the coin. And electrolyte AgCl is not aqueous. They've just written it here to confuse you. AgCl is a white precipitate. It's an insoluble salt, an insoluble compound, because we know our solubility rules. If you talk about group 7, the solubility rules for group 7 was all group 7s are soluble except for LMS. LMS stood for lead, mercury, silver, and that's silver, so it's insoluble. That's why C is wrong and D is the right option, because we know that all nitrates are soluble. Okay. An endothermic reaction is shown. First of all, let's check which one is endothermic. Bond breaking. Endothermic is the type of reaction in which the energy taken in during bond breaking is more than the energy released during bond formation. So A is an endothermic reaction. If I check B out, the energy taken in during bond breaking is less than the energy released during bond formation. That's why B is wrong. If I check C out, the energy taken in during bond breaking is less than the energy taken in during bond formation. That's basically exo, so C is also wrong. And then if I check D out, the energy taken in during bond breaking is more than the energy taken given out during bond formation. So D is also right? Now between A and D, which one should be the right option? It's saying that activation energy is X, right? And activation energy is from the reactants all the way to the top. And that is shown right here, from the reactants all the way to the top. That's why A is the right answer. Here you are basically given the activation energy of the products. No, we don't care about that, right? It's from the products all the way to the top. That's wrong. Reactants, it should be reactants, right? From the reactants all the way to the top. Okay. The formation of the liquid water from hydrogen and oxygen may occur in 3 stages. Which stages are endothermic? Endothermic would be those in which bond breaking is taking place, right? So if you check this out, hydrogen and oxygen were basically in the form of molecules, and now if you check this out, you have it in the form of atoms, 4 H atoms and 2 O atoms. So what has happened is you had 2 hydrogen molecules, you've broken these bonds, and you had 1 O2 molecules, you've broken these bonds. So obviously this is endo. It's shown that 4 H's are here now and 2 O gaseous atoms are here, so that's endo. If you check this out, 4 H's and 2 O's, they combine together to give you guys H2O. Now since H's and O's are forming a bond together, that's why bond formation is exo, so that's not the right option. If you check C3 out, you're going from a gas to a liquid, and going from a gas to a liquid means that, because we know that gases have more energy than liquid, right? And going from a gas to a liquid would mean that the extra energy that the gas particles possess would be given out in the form of heat, and therefore that's also exo. That's why 3 is the wrong option, so only 1 would be B. Yeah, that's good. And fourth, blah, 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 excess of marble pieces. You have nitric acid is added to excess of marble. So nitric acid is my limiting reactant. Okay? So if you change the concentration of nitric acid, it's also going to change the amount of carbon dioxide that's going to be produced at the end, because if nitric acid becomes limiting, the concentration would not just only change the rate of reaction, rather it would also dictate the volume of carbon dioxide being produced, and we've discussed this in class के Y. ठीक है? in all four experiments, the volume of nitric acid is the same. Volume is the same. Excess marble chips are used. So why do you have such graphs? Because you're varying the concentration of nitric acid, right? So one would have a greater concentration of nitric acid compared to 3, 2 would have more compared to 3, and so on and so forth, right? The concentration or temperature or both concepts. So okay, the temperature cannot change the amount of carbon dioxide being produced. That can only be now dictated by concentration. Temperature can just speed up the rate of reaction, right? So we know that okay, something is gonna be happening with the concentration, right? The results are shown. Which statement is correct? A lower concentration of acid is used. Just give me 1 sec, guys. Yes, okay. So it says a lower concentration of acid is used in experiment 3 compared to experiment 1. Absolutely, that's true, because experiment 1 is actually giving you guys a greater volume of carbon dioxide compared to 3. So obviously one would have, and it also has a greater rate of reaction, right? So obviously one has a greater concentration compared to 3, and that's what it's saying. A lower concentration of acid is used in 3. 3 has a lower concentration compared to 1. So A is automatically right. If you check B, C, and D out, experiment 4 is faster than experiment 3. No, 3 finishes here and 4 finishes after that. So that's absolutely BS. That's crap. The acid used in experiment 2 is of a lower concentration than in experiment 1. That's not true, because the thing is that the volume of carbon dioxide produced is the same here, right? And we know if our concentration, if our acid is the limiting bit, then the change in concentration would also affect the volume of carbon dioxide being produced, right? And they both end here at 5 minutes. So that's also crap. The temperature of the acid in experiment 1 and 2 are the same. The temperature cannot be the same because one has a greater rate of reaction compared to 2, right? So D is the wrong option here, right? For C, what you could think is they don't finish at the same time. Sorry, my bad. For C, they don't finish at the same time. This one, number 1 has finished right here, and number 2 has finished right here. My bad. Okay, so that's why C was wrong, and D is also wrong. Okay. Moving on. The equation shows the reaction for the manufacture of ammonia. Which change will decrease the activation energy? The activation energy is only dictated by the catalyst in a reversible reaction. And in any reaction, if you want to decrease the activation energy, you use a catalyst. Because what is a catalyst? A catalyst is any chemical substance that provides an alternative pathway for the reaction to occur by lowering the activation energy and therefore increasing the rate of reaction. So adding the catalyst, right? And so obviously B, C, D are wrong because they just, decreasing the temperature, decreases the rate of reaction. This has nothing to do with activation energy. Concentration has nothing to do with activation energy. So does pressure, right? And all three have nothing to do with activation energy. Moving on. 22 says a reversible reaction is shown. Which changes increase the mass of precipitate formed? You have one precipitate that's solid. Precipitate means a solid substance, right? And these three are aqueous liquid. Now it's saying adding more water. If you add more water to it, that means that this actually increases. So what will the system want to do? The system will want to decrease it. How does it decrease it? By forming more of the products. That's why this would actually increase the mass of the precipitate form. One is right. Adding aqueous sodium hydroxide. If you add aqueous sodium hydroxide, you have an acid here. So the acid would react with aqueous sodium hydroxide to undergo a neutralization reaction, and it would decrease the amount of acid here. So if the amount of acid is being decreased here, what would the system want to do? The system would want to increase the amount of acid. And how would it do that? By making more products. So obviously this would also increase the the mass of precipitate, because if more products are formed, automatically this is also a product that is being formed here. Adding dilute hydrochloric acid. If you add more HCl here, therefore you're increasing the concentration of hydrochloric acid. The system will want to decrease the amount of or the concentration of hydrochloric acid. Therefore, it'll shift the equilibrium to the left, forming more reactants, and therefore the mass of this precipitate would actually form because they would decompose back into your reactants. So 3 is wrong, 1 and 2 are the right options. Therefore, A is correct, Torino. Moving on, sulfur trioxide is produced by the reversible reaction, blah, blah, blah. Which change in conditions would produce a greater amount of SO3 at equilibrium? Adding a catalyst does not change the position of the equilibrium. It just speeds up the rate of the reaction, right? Increasing pressure. Increase in pressure favors less number of moles of gas, and we've discussed all the whys. Less number of moles of gas are on which side? Here you have 3 moles of gas, and here you have 2 moles of gas. So obviously this would have been increased, right? So which would produce greater amount of SO3? Increasing the pressure pressure. Increasing the temperature, this is an exothermic reaction, right? So forward is exo, backward is endo. If you increase the temperature, increase in temperature favors endothermic. That's why the backward reaction is favored. The equilibrium shifts to the left, more reactants are made, and the amount of SO3 decreases, right? And removing SO2 and O2, if you're removing these two, the system will want to, increase the mass of SO2 and O2, right? So the system will shift the equilibrium to the left and decay SO3 into making more SO2 and O2 because the system does not want to be disturbed. It's a badass, yeah? So D is wrong. 24 says iron 2 ions react with chlorine. Which statement about this? Okay, it's reducing agents. So all talking about reducing agents and oxidizing agents. Let's first write the oxidation state. So iron is +2. Chlorine is a pure elemental state, it's 0. Iron here is +3 and chlorine here is -1. So there has been a decrease in oxidation state for Cl2 from 0 to -1. Therefore, I could say it has been reduced and it's an oxidizing agent. And from +2 to +3, iron has been oxidized and therefore we can safely call it a reducing agent, right? And I've discussed this in quite a lot of detail in my classes ki kyun aise hota hai, but for now we know that something that's been oxidized is a reducing agent, something that's being reduced is an oxidation. Why? We've done it in class, right? So what is happening? Chlorine is reduced. Chlorine is absolutely reduced by the iron 2+ ions, right? So chlorine is reduced because iron 2+ ions are reducing agents. So that's true. B says chlorine is the reducing agent. No, chlorine is being reduced, so it's the oxidizing agent. B is wrong. Iron 2 ions are reduced. No, iron 2 ions are oxidized. You're going from +2 to +3. There's an increase in oxidation state, therefore it's oxidation, right? Iron 2 ions are the oxidizing agent. No, they are reducing agent because they are getting oxidized itself and they're reducing this chlorine. So A is the right option. Which reactions involve oxidation and reduction? Chlorine gas reacts with aqueous potassium iodide, Cl2 plus Ki. We know that chlorine is more reactive than iodine. It's going to displace it. You are going to get KCl plus I2, and it's obviously a redox reaction because it'll both, obviously if oxidation is there, reduction would automatically be there. See, chlorine is 0, iodine is -1. Here, we don't talk about K, it's the spectator, and K is +1 here, +1 here, nobody cares. But here Cl is -1 and I is 0. I2 is 0, right? So I is going from -1 to 0 and Cl2 is going from 0 to -1. That's how I is being oxidized and chlorine is being reduced. So yes, that's basically a redox reaction. Dilute sulfuric acid reacting with magnesium. Magnesium plus H2SO4, that's also a redox reaction because magnesium would displace the hydrogen. It's more reactive than the hydrogen present in the hydrogen in the acid. Therefore, it will displace it to form MgSO4 plus H2 gas. Check this out. Am I writing H2 gas? Here magnesium was 0, it's pure elemental state. Hydrogen is +1, sulfur is +6. How do I know? We calculate it, right? So hydrogen is +1, you have 2 of those, you times it by 2. Sulfur, we don't know, that's X. Oxygen, you have oxygen's oxidation state is -2. How many of those are present? 4, so times it by 4, and the overall oxidation state of any compound is 0. Why? We've done all of that in our classes. X would be equal to +6. Oxygen again is -2. Here magnesium is +2. Here sulfur, whatever it is, oxygen is -2, hydrogen is 0, right? So you could see a visible change from magnesium going from 0 to +2 and hydrogen is going from +1 to 0. So yes, it is a redox reaction, right? Oxidation and reduction both are taking place because there is an increase and decrease in oxidation states. Dilute hydrochloric acid reacting with sodium hydroxide. Obviously acid-base reactions are not redox, and you could check this out. NaOH plus HCl gives you sodium chloride and water, right? So water plus NaCl. How do I know that? I know that because the OH and the H would give you water and the Na and the Cl would form the salt, which is NaCl. And if you write the oxidation state, Na is +1, O is -2, H is +1, you have H as +1, you have Cl as -1, H again here is +1, O is -2, Na is +1, Cl is -1. There is no change in oxidation state of literally anything. That's why 3 is wrong. And you could have just used the common sense acid-base reactions are not redox. That's why 2 and not 2 and 3. That's why 1 and 2 are the right options. Okay. Which statement about weak acids are correct? Weak acids are those acids which partially dissociates when dissolved in water, or you can say which partially ionizes when dissolved in water. So they partially dissociates in aqueous solution. Yes, A is right. They do not act with alkalis. Yes, they do. They do not react with metals. Yes, they do. No, they don't. No, they do. Not yes, they do. No, they do react. Yeah. They form solutions with pH values from 0 to 2. No, that's wrong because 0 to 2 means it's a strong acid. That's why D is wrong, right? They form around 5 and 6, and so on. A colorless solution of pH 13 is tested separately with methyl orange indicator. With methyl orange, if it's pH 13, methyl orange is red in an acid and it's basically yellow in a base, right? So red in an acid, yellow in a base, and pH 13 means it's a base, so therefore it should be yellow. A and B are wrong. With thymolphthalein, this has recently been added. Thymolphthalein is blue in a base and colorless in an acid, right? If I'm not wrong, right? So blue in a base, and obviously this is a base, therefore C is the right option. Let's color it with blue. Yeah. Which pair of reagents is suitable for preparing a pure sample of copper 2 chloride crystals? Obviously, copper 2 chloride is basically a soluble salt. So what needs to be done is you could either take copper, you could take copper oxide, or you could take copper hydroxide, and you could, react it with excess acid. And then we know that our excess technique, right? We called that the excess method, in which we added the acid in excess, and then we later on performed filtration and so on and so forth, right? But the problem here is that if you take, and we took an acid, right, and here you could take like nitric acid, HNO3, but the problem is that you can't use copper in this case. For all the other metals you could have used, like magnesium, you could have used pure magnesium too, but the reason why you can't use pure copper is because copper is less reactive than hydrogen, therefore it cannot displace this hydrogen in NO3. That's why you can't use the pure metal, you have to use an acid base reaction here, right? So you either use copper oxide or copper hydroxide to react with HNO3, because then the acid base reaction would take place. Displacement cannot take place because copper is less reactive than hydrogen. So aqueous 2 copper nitrate, no, that's absolutely wrong, man. You take a copper hydroxide or a copper oxide. And it says copper and aqueous sodium chloride, again that's wrong. Copper and aqueous sodium chloride is wrong in this test because sodium is more reactive than copper, therefore copper can displace this sodium and form copper chloride. Okay? Copper and dilute hydrochloric acid, this would be right for all the other metals which are more reactive than hydrogen in the reactivity series, but since copper is lower, that's why this is wrong. And then D is copper oxide plus dilute hydrochloric acid. Yes, acid base reaction would take place. D is the right option. Element X forms an oxide of formula X2O5. In which group of the periodic table would this be formed? You could just do a simple trick, which is take these 2 and 5 back as their charges. So X would get the 5 back and O would get the 2 back, and we know O is 2 minus, therefore X should be plus 5, right? And therefore it should be in which group? It should be in group 5, because group 5s have 5 outermost electrons that they can lose, right? Or they could actually gain 3, but here, since it's making a positive ion, we could simply deduce that because it's in group 5, therefore it would be able to lose all the 5 valence electrons and make an ion of 5 plus. That's why C is the right option. The diagram shows the structure of an alloy. Which statement is correct? Okay. Alloys can only be formed by mixing copper. No, not only, because you could mix copper with zinc, that would give you brass. You could mix copper with tin, that would give you bronze, So that's the thing, man. You could make, not only, you could make it with other things. You could take iron, nickel, carbon, to make stainless steel, right? So A is wrong. Carbon and iron are the only 2 elements in stainless steel. No, it's also chromium and nickel, so that's also wrong. They're not only. See, the keywords are, you have to read the question carefully. C says, in an alloy, there is an attraction between positive ions and a sea of delocalized electrons. Yes, that's true, because, you use at least one metal in an alloy. And what is the property of metals? They have, they have a lattice of positive ions and a sea of delocalized electrons. That's why alloys can also conduct electricity, right? Because, alloys be having those metals, a mixture, right, of metals and any other elements with it. So if you have a metal, since it's a mixture, the metal would have the metallic properties that it does, right? So C is the right option, although it'll be weaker compared to a pure metal, but they'll still be there. The alloy brass has a chemical formula. No, it has no chemical formula, because alloys are mixtures, they are not compounds, therefore they won't have any chemical formulas, right? Because brass is made up of copper and zinc. Yeah, if I'm not wrong, yes, copper and zinc, right? So brass is made up of copper and zinc, so it doesn't have any chemical formula. You just say it's a mixture of copper and zinc, right? So mixtures don't have chemical formulas. Which compounds has the lowest percentage by mass of nitrogen? You could just do is that 2 times n, that would give you 28, because n is 14, and then divided by the total, which is part by whole. How do you find percentages? Part by whole into 100%. You could just do that. That's 28 over 60. 2 times n, that's again 28 over 132, and then here you have 3 times n, so 3 times 14, that gives me 42, right? So 42 over 149, and then here you have n and n, so you have two n's, which is basically 28 over 80. So if you find this out, 28 over 60 gives me 0.4667, right? So that's basically like 46.7%. You can multiply it with 100 if you want. I don't want to do it because I don't care. 0.212, and that's actually 42 over 149. That gives me 0.281, and then here 28 over 80 gives me 0.35. So which one is the lowest? Obviously B is the lowest. That's why that's the right option, because it's asking you the lowest percentage by mass. The diagram shows structures of 5 hydrocarbons. Which 3 hydrocarbons are isomers of each other? What were isomers? They were compounds having the same molecular formula and I'm so tired, man, and different structural formula. So first of all, the molecular formula would be the same, right? And if you check them out, I can see some ambiguity here, because see, 1 2 3 4 5, these are 5 carbons right here, okay? And here if you check 2 out, you have 1 2 3 4 5, so these are also 5 carbons. So 1 and 2 are isomers of each other, because obviously visibly the structures are different, and I've also taught you how to name them. If you check 3 out, you have 1 2 3 4, so here you have 4 carbons. So obviously 1 and 2 are isomers, but 1 2 and 3 are not, 1 and 2 are not isomers with 3, because first of all they aren't even meeting the first conditions, which is that they should have the same molecular formula. If you check 4 out, 1 2 3 4 5, you again have 5 carbons, and automatically these 3 are isomers with each other, 1 2 and 5. And if you check part 1 2 and 4, and if you check this 5 hydrocarbon, it has 1 2 3 and 4. So obviously 3 and 5 are, you know, isomers, and 1 2 and 4 are isomers, right? And saying which 3 hydrocarbons are isomers, so it's 1 2 and 4 is the right option. The diagram shows the fractionating column used in several. Which row explains why fraction R is collected above S? Obviously, as you go above, the temperature of this fractionating column decreases. There's like a heat gradient. Upper is a cooler temperature, up like 25, 35, and here it's the hottest, right? Because obviously it's being heated here, and the hottest temperature is here. So the molecules that are going to be longer, that'll have a greater melting and boiling point, that'll have a greater mass, and so on and so forth, would be collected at the bottom. The one that'll have lower melting and boiling point and lower masses and lower plana timcana, they would be collected at the top. So which row explains why fraction R is collected above S? Because R would obviously have a lower boiling point than S, because S is collected at the bottom, it needs greater heat, right? So R has a smaller boiling point than S, therefore C and D mein option hai. And average molecular mass, so if it has a smaller boiling point, that means that it's going to be a smaller molecule, so the average molecular mass of R is also going to be smaller than S. Which compound is an alkane? For a compound to be an alkane, it should fit the general formula, which is CnH2n plus 2, which is how the number of carbons there are, hydrogens will be twice the number of that plus 2. Check this out. If I check this out here, that's absolutely crap. Here carbon, say, that's also crap. Number of carbons are 31. 31 times 2, that's again not giving you, 31 times 2 is 62, but you also have to plus 2, right? So if I want to find out, a compound which is an alkene which has 31 carbons, you'll have to plug in 31 instead of the N, and you get C31. H2 times 31 is 62. 62 plus 2 is 64. So D is the right option, yeah? Which row correctly describe alkenes? Alkenes are unsaturated hydrocarbons, and that's how we learned all the reactions, because they had the double bond, which meant unsaturated. D and A and B are wrong. And result when aqueous bromine, they decolorize the aqueous bromine, right? Because the bromine, actually Br2 aqueous, which is orange, it reacts with the double bond and it forms a colorless solution, right? So the aqueous bromine is decolorized. That's why D is the right option. Carboxylic acid with the molecular formula C4H8O2. Those of you who I have not taught this method, you guys could just, simplify it for yourself by saying COOH should be written separately and just minus it from the 2, so you'll have C3H7, right? So minus COOH from this, 2 O's and 1 C, so you are left with C3H7, right? Or you could just write down the molecular formula in your own words by using the general formula, which was CnH2n plus 1 COOH, right? That was the easier way to go about it. Okay? So what was I saying? Yeah, so that's the carboxylic acid that you have, which has 4 carbons, and you have a 3 carbon, what's it called, alcohol, right? So 3 carbon alcohol is basically your propanol, And a 4 carbon carboxylic acid is butanoic acid. And when butanoic acid and propanol, they react, when you provide, concentrated sulfuric acid and a temperature of 200 degrees Celsius, what would happen is an ester would be formed, which would be called, the alcohol's name would change from propanol to propyl, and butanoic acid would become the salt name, which would be butanoate, right? So propyl butanoate would be formed. Now, how do we identify it? The C, you could also make it, but the C double bonded to the O, and towards it, the number of carbons that are attached would represent the acid bit, and the ones that are directly attached to the O, the carbons that are attached directly to the O, these would represent the alcohol bits. And we've done this, right? So if you check this out, you have meth eth prop, you have propanoate, and meth eth pro but. So you have butyl propanoate right here. A is the wrong answer. If you check B out, you have how many carbons on the acid bit? 1, 2, 3, 4. So that's basically meth eth pro but, that's butanoate. And meth eth prop, you have propyl right here, because that's the alcohol, because alcohols are directly bonded to the O, whereas carboxylic acid se jo bit aaya hota hai, that's C double bonded to O, and those are bonded more further to the carbons, right? So that's basically propyl, that's the alcohol bit, and that's the butanoate bit. So propyl butanoate, that's why B is the right option, right? C is basically meth eth pro but, that's butanoate, but it's meth eth pro but, it's butyl butanoate. And this is meth eth prop, that's propyl, meth eth pro but, meth eth pro. So it's propyl propanoate, propyl propanoate, butyl butanoate, and the above one was butyl meth eth pro propanoate, right? So they were all wrong. B is the right option. The repeat unit of the polymer is shown. What you could do is just finish the continuity bonds and make a double bond between them. So C double bonded to C, that's CH3, that's Cl right here, that's H, and that's Br, right? So if you check between A, B, and C and D, which one is the right answer? The Cl and the Br should be on one carbon, and the CH3 and the H should be on one carbon, regardless of whether they've mixed this up, ke H ko upar likho aur CH3 ko niche likho aur put the Br at the top and Cl at the bottom. It doesn't make a difference, right? But this makes a difference, that they should be on the same carbon. So the first carbon should have, or maybe if it's oppositely written, nobody cares, but one carbon, the carbon on the left or the right, should have CH3 and H with it, right? So if you check this out, what this carbon has a CH3 and Br with it, that's why C is wrong. This carbon has a CH3 and Cl with it, that's why C and B are wrong. And if you check this carbon out, it has a CH3 and Br with it again, so this is also wrong. Therefore A is the right option, which has the CH3 and the H, and one carbon has the Br and the Cl, and that's what is showing, CH3 and H, and this one has the Cl and the Br. Oh, I'm so tired, man. This is such a lengthy paper. When heated, magnesium reacts with oxygen. Okay, magnesium reacts with oxygen to give you magnesium oxide. And it says that a white powder. Magnesium oxide is a white powder. Note what the examiner is telling you, right? And a student investigates the change in mass that occurs during this reaction. The student is given a balance and 3 sets of apparatus shown. Which sets of apparatus are suitable? So he's given a balance so he can measure the change in mass. But let's see what so he needs magnesium, and he needs it to react with oxygen to form magnesium oxide, and he should be able to weigh it with a balance accurately. The problem with number 1 is that magnesium is burning, so magnesium is reacting with oxygen. But the problem is that magnesium oxide is being formed, and they're saying that it's going to be a white powder. So if you just do it like this, if you perform this experiment like this, you're just going to be stupid, because the powder that's going to be formed is going to be, going everywhere, so you won't get accurate results on the balance, right? So that's basically common sense, man. That's why 1 is an inaccurate way of doing it, and that's basically the student is just stupid, right? If you check 2 and 3 out, 2 and 3 are the right way to do it, because you are providing air, which is basically oxygen, and the oxygen in the air would react with this magnesium to give you magnesium oxide powder. And because it's the powder is not going to go anywhere, you could just measure it on a balance, and you need the heat to make this reaction take place, right? And again, in a crucible, you heat it, you use metal tongs, and you've covered this up, and magnesium is inside, and obviously you have the air inside it too, right? If there's nothing, obviously it means that air is present. So this magnesium would react with the oxygen in the air, and magnesium oxide would be formed, which is a powder, and it would be collected here, and then you could measure it on a balance. And this is actually the most accurate way to do it, and obviously this too. So 2 and 3 are both the accurate way. That's why C is the right option. And one other way to think about it is that whenever you perform an experiment, you don't want to react everything, right? Here it's basically like not controlled, right? The magnesium will keep on burning, and it'll just finish, right? Here you could just control it as you want. You stop heat, you control. Here you can't, because magnesium is very reactive. It's continuously reacts, it gives you like a white flame, brilliant white flame, and it's done. And C may, you could also, you know, what's it called, you can also control the heat, right? Because you just stop the heat and your experiment is finished. So here you could control your experiments, here it's out of control. 39 says a student uses paper chromatography to find the RF value of Fe3 plus. Now obviously Fe3 plus would give you a red brown, you know, a red brown what's it called, observation, right? It gives you a red brown solid when it reacts with the hydroxide, gives you iron hydroxide. Fe3 plus gives you a red brown, you know, observation, and Fe2 plus gives you a green precipitate. This gives you a red brown PPT, this gives you a green PPT, right? And I gave the example of an apple. Apples have iron 2 plus. If you let it, you know, if you let it rot on the side of a side table, it becomes brown with time because the iron 2 plus gets converted into iron 3 plus. So to make this spot visible, blah blah blah, he sprays it with sodium hydroxide, so iron or hydroxide is formed, which is a red brown PPT. It says under the condition of the experiment, how do you find the RF value? RF value is basically defined as the distance covered by the component or the analyte to the ratio of the distance covered by the analyte to the distance covered by the solvent front, which is y. So y, x over y is going to be, you know, the way you would calculate the RF value. And then between gap 2, it says if it's green or red brown. Obviously iron 3 oxide, iron Fe3 plus reacts with OH minus, gives you FeOH thrice, which is iron hydroxide. And iron hydroxide is, if it's an iron 3 plus ion, it's basically red brown, not green. So B is the right option. Test on an aqueous solution of an unknown compound P are shown in the table. Aqueous sodium hydroxide is added. It gives you a green precipitate. It could be Fe2 plus or Cr3 plus, but it says it's soluble in excess, giving a green solution. We know that iron 2 plus is insoluble in excess, so therefore Cr3 plus should be your ion, right? So between A, B, C, D, C and D are automatically wrong. Between the chloride ion and the sulfate ion, if you add dilute nitric acid and you add you know, aqueous barium nitrate, white precipitate is formed, which is basically a test for the sulfate ion, because what happens is the dilute nitric acid is added to remove any impurities, but barium nitrate, once you add that stuff, you know that if there is a sulfate ion, barium nitrate is soluble, right? So it gives you the Ba2 plus ion and the NO3 minus ion, and barium sulfate is formed, which is a white PPT because barium sulfate is insoluble. So yes, sulfate was the ion, the negative ion. Chloride क्यों नहीं है? Because if you check the next test out, it says aqueous silver nitrate is added and no precipitated form, which is basically an indication that the chloride ion must not be present, because if you add aqueous silver nitrate and the chloride ion was present, silver and silver ion and the chloride ion would react together to form a white precipitate, which was a GCl, right? And that's basically how we get full marks in our paper, and that's the end of this past paper. Damn, I'm tired, guys. I hope you guys enjoy it, and you know, share it with those who need this help. Take care, guys. Bye bye. Ciao.